Hello, happy Friday. I am going to go through some more three variable systems. The first thing I'm going to do in fifth period, I apologize, you already saw this one. I'm going to do the practice problem that we did at the end of class because in fourth period I didn't get a chance to show everyone. So our system was x minus 2y plus z equals -4, -4x plus y minus 2z. And it goes without saying, but if you already saw this one, you can fast forward, unlike in real life when you just have to keep sort of listening to me. 2x plus 2y minus z equals 10. Okay, so our first step generally is to try to pick two equations and eliminate a variable. So if you did, I mean, you could do any of these, right? If you notice that if we put the top and third one together, things will automatically cancel, maybe you started with that. So x minus 2y plus z equals -4. 2x plus 2y minus z equals 10. So if we add these together, we get 3x, -2y plus 2y is no y's, z plus -z is no z's, -4 plus 10 is 6, so we get to solve for x already. So we can divide by 3 on both sides and we get x equals 2. So here's where you have actually a lot of options. So if you wanted to, you could plug that x equals 2 into actually all of the equations, right? And so you could go up here and say, now really this is 2 minus 2y plus z equals -4. This is now -4 times 2 plus y minus 2z equals 1. 2 times 2 plus 2y minus z equals 10. Sorry, that was supposed to be a 1. That does not resemble a 1. And then from here, we could actually rewrite these again. And so if we take this one and subtract 2 from both sides, I have -2y plus z equals -6. This next one, that's really -8 plus y minus 2z equals 1. Add 8, y minus 2z equals 9. And then we can take this last one, and that's really the same as 4 plus 2y minus z equals 10. Subtract 4, 2y minus z equals 6. So one option is, now we have 3 equations with 2 unknowns. So we can set up systems. You could do any pair of 2 of these and you'd have 2 equations just with y and z defined, and you could solve for y and z that way. So that's one option. If you don't want to do that, I'm going to erase this. Obviously, you can go back in the video and it'll be there. If you like to stick with the steps, sorry about that delay. If you like to stick with the steps, let's say we're here and we have x equals 2. We can actually just now go back and solve for different variables. So let's put the first 2 equations and the second 2 equations, and really if we're thinking of our steps, do steps 1, 2, and 3. Because we did step 1 and we were like, oh, I guess we have x, but now let's take 2. So let's do x minus 2y plus z equals -4, and -4x plus y minus 2z equals 1. So I am going to, let's see, I need my coefficients to match, right? And I have a, x's I have a 1 and a -4, y's I have a -2 and a 1, z's I have a 1 and a -2. Let's cancel out, you know what? Let's cancel out our x's, okay? So let's multiply by 4 on top and bottom. So now we'll have 4x minus 8y plus 4z equals -16. and then we'll bring down our negative 4x plus y minus 2z equals 1. To get my x's to cancel, I add 4x plus negative 4x is 0, negative 8y plus y is negative 7y, 4z plus negative 2z is 2z, negative 16 plus 1 is negative 15. Now let's take the bottom two. So negative 4x plus y minus 2z equals 1, 2x plus 2y minus z equals 10. Let's see, nothing matches as is, and we need to cancel out x's because that's what we did up above. So we need to do that again. So in order to make those coefficients match, I'm going to multiply the bottom by 2. Bottom equation, I mean. So top equation stays, negative 4x plus y minus 2z equals 1. Bottom equation turns into 4x plus 4y minus 2z equals 20. So now, to make our x's cancel, we will add negative 4x plus 4x is nothing. 1y plus 4y is 5y. Negative 2z plus negative 2z is negative 4z, and 1 plus 20 is 21. And so now what we have is two equations with y and z. And here's where we're back to our steps. Now we can use number 3 and solve for a variable using those two equations. So negative 7y plus 2z equals negative 15. 5y minus 4z equals 21. There's a system. I want to cancel something out. 5 and 7, that looks annoying, but I can multiply the top by 2, and I'll have a 4z and a negative 4z. So top, we have negative 14y plus 4z equals negative 30. Bottom, 5y minus 4z equals 21. We'll add again to make our z's cancel. Negative 14 plus 5 is negative 9y. Z's are gone. Negative 30 plus 21 is negative 9. Divide by negative 9, so y is 1. And now I can go back to one of these equations up top. Let's take that one. Why not? 5y minus 4z equals 21, and I'll put that y I just found in there. So 5 times 1 minus 4z equals 21. 5 minus 4z equals 21. Sorry for that pause. Negative 4z equals 16. So z is negative 4. And I actually now have found everything I want. So I have x, y, and z, and so my final answer is the coordinate point, not a pair anymore, coordinate trio, I guess, 2, 1, negative 4, in x, y, z order. And there are so many different ways you can do this. I would usually at least start with the steps because it gives you a place, something to start writing down, but any number of orders is fine, and you can always plug these into all three original equations to make sure they work. Okay, I'm going to show you a couple more. And if it helps, they're actually easier ones, which may or may not be good. Let's do x plus y minus z equals negative 4. X plus y plus z equals 2. And y equals negative 2. So you're starting out with we, you, whomever, I don't know. We're starting out with one of the variables, so we already know what y is. And so kind of the best thing to do here is to plug that y in. So I know that y is negative 2, so I'll plug it in here and here. So now I have x plus negative 2 minus z equals negative 4. Add 2 to both sides. X minus z equals negative 2. Great, there's one. Let's do this one here. So x plus negative 2 plus z equals 2. Add 2 to both sides. X plus z equals 4. Well, I already have y. Now I'm going to use these. Again, I have 2 variables left, so I only need 2 equations in order to solve. So x minus z equals negative 2. X plus z equals 4. If we were in class, I'd say, do you want to add or subtract? I feel like adding, so that's what I'm going to do because I can't hear what you're thinking. So x plus x is 2x, negative z plus z is nothing, negative 2 plus 4 is 2. 2x is 2, so x is 1. So I have x and y. Last piece here, if x plus z is 4, I could use x plus z equals negative 2 as well. Then 1 plus z is 4, and z is 4 minus 1, which is 3. So for this one, my coordinate pair is we go in x, y, z order, alphabetical, right? Normally x, y, we're just adding a z on the end. So 1, negative 2, 3. Let's do one more. At least I'm going to show you one more, and for all I know, you stopped watching this video long ago, or never opened it. I don't know. X plus y minus z equals negative 2. X minus y, I'm going to leave a space, equals 5. 2x minus y plus 3z equals 10. Once again, lots and lots of options. What I'm going to do, though, is just treat it like any other system of equations with 3 variables and use my steps. So first I'll combine 2 equations to eliminate a variable. So let's combine the top 2. So x plus y minus z equals negative 2. X minus y equals 5. You can add or subtract. Let's subtract. I tend to add, so let's subtract. X minus x is 0. X is 0 anythings. Y minus negative y is 2y. Negative z minus nothing is just negative z. Negative 2 minus 5 is negative 7. Now let's do, so we have an equation with 2 variables, right? Just y and z. Now let's do the bottom 2. And you could do the top and bottom if you want, doesn't matter. X minus y equals 5. 2x minus y plus 3z equals 10. I want to get rid of the same thing again, the same variable again. We got rid of x's last time, so we have to get rid of x's again. So it looks like our x coefficients need to match. 2x on the bottom. If I multiply the top equation by 2, I'll get 2x on the top. So I'll bring this down. So I have 2x minus 2y, no z's, but I'll leave a space, equals 10. And I'll bring down 2x minus y plus 3z equals 10. To make my x's cancel out, I must subtract. So let's do that. 2x minus 2x is nothing. Negative 2y minus a negative y is negative y. This is nothing minus 3z is negative 3z. And 10 minus 10 is 0. So now I have these 2 equations with only y and z in them. So I'll put them together over here. 2y minus z is negative 7. Negative y minus 3z equals 0. So here's a system. Nothing really matches. What should we do? Looks like, if we want the top to cancel out z's, let's say. You can cancel out y's too, it doesn't matter. But I see a negative 3z, so if I multiply the top by 3, or negative 3, this will work for us. So we'll have, this bottom one will come down, so we'll have 6y minus 3z plus 21, not plus 21, equals 21. Totally different. Bring down the second, negative y minus 3z equals 0. Now, in order to cancel my z's, negative 3z plus negative 3z would give us negative